So this unit is vitamins and minerals. I'm going to break it down into short video clips of 5 to 10 minutes because this information is going to be a little bit tedious. There's a lot of different vitamins and minerals. Each have different functions, food sources, deficiencies, toxicities, etc. And I'm going to focus on the main ones that people have issues with and give you a really good resource. Actually, two actually really good resources. This is the Linus Pauling Institute, one of my favorites. You can just Google Linus Pauling Institute. It's from Oregon State University, and they have information on all of the different vitamins and minerals as well as phytochemicals. They actually do have a section right now front and center on the immune system since that's such a pertinent topic today with COVID. I'll talk about some of the issues of vitamins and minerals, some of the misinformation going around right now surrounding supplements and COVID later. So we'll start with the vitamins. Vitamins are essential nutrients, that is, they're needed in the diet, but the body can't make them. That's what an essential nutrient is. There is one exception. Vitamin D can be made in the body, but not in sufficient amounts. So as far as the functions of vitamins, one of the functions is that they assist in the body's chemical reactions. Enzymes often cannot work without a specific vitamin attached to them. For example, vitamin C is needed to help the enzyme that makes collagen. So collagen is a connective tissue. It also is a major component of arteries, and collagen makes up your scar tissue. So we'll talk more about that a little bit later. Vitamin B6 helps in an enzyme that is involved in protein synthesis. Now, this is a graphic of how enzymes work. The yellow part is the enzyme without its coenzyme attached, and it cannot work. So in the second picture, you see the enzyme, which is called the coenzyme, is attached to the enzyme, and now the substrate can fit into that enzyme so that the enzyme can work. So here is a video. I'm going to show you one of these two videos on enzyme action. Now, these videos don't show that the vitamin is attached to the enzyme in order for it to work, but this is the basic illustration of how enzymes work. Just assume that the enzymes have their coenzyme already, which is a vitamin, already attached.
Enzymes enable molecules called substrates to undergo a chemical change to form new substances called products. Each enzyme acts on a specific molecule or set of molecules called substrates. Each substrate fits into an area of the enzyme called the active site. This fitting together is often compared to a lock and key mechanism. However, the enzyme changes shape a little to fit with the substrate. In the enzyme-substrate complex, the enzyme holds the substrate or substrates in a position where a reaction can occur easily. After reaction, the enzyme releases the products and can go on to carry out the same reaction again and again.
Okay, so if you open the PowerPoint that I uploaded, you can see the next video, but it basically shows the same thing. Okay, come on, video. Okay, there we go. So another function of enzymes is that they protect cells from environmental damage. And those are the antioxidant vitamins, vitamins A, C, and E. And I remember it as the antioxidant vitamins are the ACEs of our body. So what they do is they intercept free radicals, which are highly reactive molecules that go around the body and damage everything they touch. I think of it as a pinball machine. The free radical is like the ball in a pinball machine, and everything it touches is damaged. So the free radicals, so the actual antioxidants destroy the free radicals and are, destroyed themselves in the process before the free radicals then can attack other body molecules. So here's a picture of vitamin E. This is a cell membrane. Remember, cell membranes are a dual layer of phospholipids, and that's often the target of free radicals. So you can see the vitamin E is there to intercept free radicals so that they don't destroy your cell membranes. There's a couple of good videos on how antioxidant works. That first link is to actually just a text website, but I'll show you one of these videos on how antioxidants work.
Our bodies are comprised of billions of molecular cells held together by electronic bonds. Sometimes these molecules are held together by a weak bond and can split apart, resulting in an unstable molecule with an unpaired electron. This molecule is known as a free radical. Some free radicals occur normally in our bodies through metabolism. However, there are many environmental factors that can cause an excess of free radicals, such as pollution, radiation, cigarette smoke, and herbicides. In addition, stress, lack of exercise, and lack of sleep. These free radicals will start attacking healthy nearby cells in an attempt to replace their missing electron. When the attacked molecule loses its electron, it becomes a free radical itself. This can cause a chain reaction to occur, resulting in the disruption of millions of nearby molecules. This chain reaction is known as oxidative stress, and many experts agree that oxidative stress is thought to be leading causes for such things as arthritis, premature aging, edema, and leg swelling, hardening of the arteries, and even an increased susceptibility to cancers. We can see the results of this oxidation in our everyday environment, such as a rusting piece of metal or fruit that's exposed to air. Think about it. If you cut a piece of apple and leave it out in the open, in a very short period of time, you'll see the surface begin to turn brown. And that's how quickly oxidation occurs. Imagine this happening in your body. It is literally decaying otherwise healthy cells. So how do we protect ourselves from these free radicals that are wreaking havoc in our bodies? Well, if the destructive process is through oxidation, then the answer is antioxidation, the opposite of oxidation. And this is achieved with antioxidants. Antioxidants stop this chain reaction by donating one of their own electrons to the free radicals. The great thing is, the antioxidant nutrient itself does not become a free radical by giving away its electron. It's kind of like a win-win situation for the antioxidant and the free radical. Scientists have created a test to measure an antioxidant's ability to pacify the free radicals in our system. This test is known as the Oxygen Radical Absorbance Capacity Test, often referred to as the ORAC test for short. Fruits are tested with this and are graded with a number, which is known as their ORAC score or ORAC value. Let's take a look how the acai berry found in Monavie stacks up to its competition. Let's start by looking at a tomato. Its ability to pacify the free radicals in our system was measured using the ORAC test and received a score of 60. A cherry was tested and its ORAC value turned out to be 100. How about some broccoli? It was tested resulting in an ORAC score of 130. A red raspberry tested at 210. A wild blueberry received a score of 260. Now let's look how the acai berry stacks up using Monavie's patented process.
Okay, I stopped it right there because this was a video created by a company that made a product that is no longer sold. It was in one of those multi-level marketing things and was removed from business. So this is going to end. You can look at that the next video is actually Alton Brown. It's kind of a funny way that that he explains antioxidant, but it's a little bit fuzzy, so I'm not going to show that one because I like the way that that video explained free radicals and antioxidants. We'll talk about the different foods. The antioxidants include the vitamins A, C, and E, but a lot of phytochemicals are antioxidants as well.